All right, class, let's move on to our next major topic. We're going to be talking about identity and access management solutions. Now, this entire domain is heavily tested on the Security Plus exam. It's all about answering one fundamental question: are you who you say you are? And should you be allowed to do what you are trying to do? So let's get started with the key concept of identity and access management, or otherwise known as IAM. So, what is IAM? It's the framework of policies and technologies used to manage digital identities. The goal here is for us to control access to resources and ensure that the right individuals can access the right resources at the right times for the right reasons. Think of it as a digital bouncer and the guest list for your entire organization. It's not just about one thing, it's about a combination of policies, processes, tools, procedures to handle everything from user creation to their deletion. So, what is included in IAM? Let's brainstorm this. IAM covers a few things. For first thing is the identification, claiming an identity. I am J. Haskell. Authentication, proving the identity itself. Here is my password. Authorization. What are you allowed to do in this process? Can you read the file, but you can't delete it? What can you do? Accounting or auditing. Keeping a log of who did it, when, and all of this stuff is going to be covered in IAM, okay? So the benefits of IAM are significant. For the exam itself, don't think about it from a security perspective. Think about it from a security perspective itself. This is where we want to look at IAM, identity. Identity and access management. IAM itself is going to have a few different things that we're going to be looking for here. For security, we want to have improved security. It's going to help us prevent unauthorized access and, well, those data breaches. We don't want to be on the White Hill. Now, regulatory compliance themselves, like regulatory bodies like SOX, HIPAA, GDPR, they're going to require strict access controls and auditing. And IAM is how we're going to achieve this. We may need centralized control to allow administrators to manage all the users' identities and permissions from one place to another, which is going to, well, reduce the errors. And then we need a better user experience. When done right, with things like single sign-on, it makes life easier for our users. So something that we need to use every day is going to be multi-factor authentication. The Security Plus definition is a security process that requires users to provide 2 or more verification factors before gaining access. The key here is always going to be the 2 or more factors. Just having 2 passwords is not MFA. The 2 factors are the same type. True MFA requires factors from different categories. So just like we've covered before, remember authorization. But remember authentication factors. Let's cover the main topics here. So, something you know, like a secret, password, PIN, answer to a security question. Maybe something you have, like a physical item. Think of it like your smartphone with an authenticator app or a USB security key like YubiKey or smart card. Something you are refers to biometrics like your fingerprint, face scan, or an iris scan. And MFA means combining at least 2 of these: a password, something I know, plus a code, something from your phone, something I have, which is a very common example here. Now, some of the more popular types refers to the implementations of MFA. Could be like authenticator apps. Think about Google Authenticator, Microsoft Authenticator, which generate a time-based one-time password, TOTP, a time-based one-time password. Maybe a push notification where you have to click approve on your phone, SMS or text message, where it may be considered with a code. Just be aware that a text message is considered one of the least secure methods of MFA. due to the risk of SIM swapping. So for Security Plus, just know that that's the least protective, but it does count as MFA. Hardware tokens like YubiKeys or RSA secure fobs, or biometrics like fingerprint readers, Face ID, etc. Okay, we need to make sure that we know the different types. Now let's talk about that first factor, the one that we all have way too many of, password security. Now this is the practice of protecting user accounts by ensuring that passwords are strong, secure, and well managed. It's not about the password itself, it's about the entire life cycle of the password itself. Now there are some key elements to passwords, so let's expand on this. A strong password policy, which you should be tested on, should include complexity, maybe requiring upper lowercase numbers, length of your password, more important than complexity. Normally 12 to 14 characters is the modern best practice. Password history, not allowing users to reuse their passwords, maybe 5, 10, or 20 of the last passwords. Forcing users to change their passwords every 90 days with password expiration. Note NIST guidelines are moving away from strong passwords, and MFA are used, but still is a common practice. We always like to say about once a year here. An account lockout, making sure that we're disabling an account after a certain number of failed login attempts occur. Like after maybe 5 attempts, we should lock out that password. Now, for some common password attacks for the exam, you should know a few of them. For instance, brute force attacks. Trying every single possible combination of characters. Maybe I get lucky. Dictionary attacks. A smarter attack, only trying words from a list like a dictionary, or a list of common passwords. A phishing attack. Maybe these are sent through like an email, and so they're trying to do some credential harvesting. Maybe rainbow attack tables, where they take an attack against hashed passwords. Now remember, hash passwords are pre-computed that looks up pretty common passwords by matching the hash to common passwords to make sure that we can maybe look it up. Remember, this is why we salt our hashes. Or even password spraying, where we could take a very common password like winter of 2025 and try it against many different accounts and seeing if anyone used that password. Now what's really good about this is it helps avoid account lockouts because we're trying it against many accounts instead of just trying the same different passwords over and over and over on the same account. Now something that tries to make our lives easier is going to be the single sign-on. Now SSO allows users to access multiple applications and services with a single set of login credentials. Once you log in once to a central system, that system then vouches for your identity, logging you into all other services like your email, help desk, HR portal automatically. Now the huge benefit is convenience and security. Users only need to remember one strong password, and admins can enforce a strong MFA account in one central place. Now, some of those SSO components are different protocols to make this work. One of the first things we need to do is we need to have an identity provider. Now, somebody themselves have to be used as the provider. They're going to handle all the authentication, the username and password. Then we're going to have what we call the service provider. The service provider is the services that the users would use. So think about this here. You can log into a school system, and most of the time you'll have something like ClassLink that will give you all the applications at your fingertips, but you only had to authenticate once through ClassLink. And then lastly, we're going to have authentication tokens. Security tokens or assertions issued by the IDP itself to prove your identity. Remember, tokens themselves are going to be, well, the next stage of this. We want to make sure that the token itself is valid for an X amount of time and maybe even gets revoked after a certain set of time, so that way we don't have any issues there. Now, a typical flow using SAML, which is pretty popular here, would be like the user tries to access a cloud application. Okay. Now the SP itself is going to see that the user isn't logged in and redirect them into a login page. This is where the IDP is going to come in. We're going to then have the user enter their username and password and maybe their MFA into the IDP. Now, if the IDP successfully authenticates them, they'll build what we call an XML token. This token will say that J. Smith is authenticated, and here are their attributes. The IDP will then give this back to the user browser and forward it onto the SP. Remember, the SP here is going to make sure that, hey, it's been validated and allow them to now use the SSO logins. Now, this brings us to a related and often confused concept of federation. Federation refers to the process that establishing trust between organization or domains. SSO is all about logging into multiple apps into your own organization from one login. Federation is about logging into an app in another organization using your organization's credentials. The way to think about this is your university and Google are in federation. And so for here, we like to use Microsoft, okay? So we can log into Microsoft using our university, the college itself, username and password, right? And now the university or the college will then act as the identity provider, and then Google or Microsoft will then trust us, okay? So federation is between domains, while SSO is all within a single domain. That's one of the big things that we always like to make sure that we understand, okay? Now, because the workflow is almost identical, I do like to show you this just in case. Just be aware that it's all about different organizations that have a pre-established trust relationship. For instance, in Wild Cyber Range, I like to use Microsoft and Facebook and Google. You can single sign on with that, and that's because I have a federated service that I trust that if you can authenticate with them and they vouch for you, then you have been authenticated through a proper system. The next term is going to be called Privileged Access Management, otherwise known as PAM. PAM refers to the tools, policies, and practices to control and monitor users for elevated privileges. We're not talking about the regular users here. We're talking about administrators, your root and admin accounts, and service accounts. These are all keys to the kingdom, and any one of these being compromised is the attacker's ultimate goal. So PAM is all about protecting our keys to the kingdom. So why do we need PAM? Well, because privilege escalation is the primary target for attackers. If an attacker steals a regular password, they might get access to some files. But if they steal an administrator password, it's game over. They could deploy ransomware, steal all the data, and erase all the logs. PAM systems are here to prevent that. Now, some things that we might use in a PAM would be a suite of tools. Just know that we may have a password vault, session management and recording systems, password rotations, or even just-in-time access. Now, just-in-time access is one of the more unique ones here that a lot of people haven't heard of before. And so just-in-time access means an admin doesn't have 24 access to their system. They must formally check out the admin password, often with a manager's approval, and they're only given access for a limited time, maybe 2 hours. And then after such time, that account then is deactivated. All right, let's move on to the A in IAM, which is authorization. This is done by using access control models. This is a guaranteed topic on your exam, okay? You must know the difference between these models. First is going to be DAC, otherwise known as discretionary access control. Make sure that you know DAC is, well, the owner of the resource gets to decide who has access to it. Data owner, okay? Think of it as a Windows file system. If you create a document, you are now the owner. You can right-click on it, go to Properties, and you can give other people access to even anyone who has access to the system. Access is determined by the owner on DAC. Next is MAC, Mandatory Access Control. And I like to call this one military access control because this is where top secret, secret, confidential, this is where all this ends. The user is going to have a clearance level, and a file is going to have a classification level. So that clearance level must match the classification level to be able to access the file. The user can't change this. Even if you create a top secret file, you can't decide to share it with a secret level colleague. Key takeaway here is security labels. It's going to be used for high security environments like the military. RBAC, like Franken Accounting. This is all about role-based. This is pretty popular. You might want to create a group called accountants, and you assign all the accountants the same type of permissions. This way they are accessed by their job function, Okay. And then lastly, we have ABAC, which is attribute based access control. And this is the newer, one of the newest models here. And the way that this works is, for example, you might want to allow a user with an attribute of manager to access a resource like financial report, but only if the environment variable time is met. For instance, maybe he only can access it between 9 a.m. and 5 p.m., and maybe only if he is accessing it from headquarters. He can't just access it from home. So, key takeaway here, attribute based, is that they have dynamic policies and attributes. It's very flexible and granular. It's kind of like row based, but also adding in other variables. All variables must equal true in order for them to access that system. Now, steps in assigning the permissions themselves. Well, you're going to identify the resources and actions. What are you trying to protect? Is it a file? Is it a database? You're going to classify the user. You're going to apply the principle of least privilege, right? What do they need to do their job and nothing more? You're going to assign whatever control type that fits your organization need. Maybe RBAC is the most popular one. Grant time access. Well, sometimes a just-in-time idea might be in there. We might want to use user access controls, saying that this file is only read only by user A, but maybe editable by user B. We're going to implement group permissions, which is basically RBAC. We don't assign users permissions, we assign groups permissions. And then we want to use PAM, making sure that admin accounts themselves use a dedicated solution. Okay. And the most importantly thing is we need to do an audit. We should review this on a regular basis. All right, that was a very dense and quick slide deck, but very important. So one of the takeaways I would say here is make sure that you understand DAC, MAC, RBAC, ABAC. Those are the big ones, and know some of your terms. Know that what PAM is, why we use PAM, and then all the IAM authentication terms: identification, authentication, authorization, accounting, right? AAA. We want to make sure that we understand why each one of those is used. Hopefully it's repeat by this stage, but if not, make sure that you know it before you take the exam. Otherwise, have a good one. I'll see you for the next one.